Hello dear students, welcome back to my channel. So let us continue with the next exercise on circles, that is exercise 17b. Alright, so before we begin the exercise, let us get familiarized with two theorems that we are going to make use in this particular exercise. So the first theorem says, in a circle, equal chords subtend equal angles at the center. Alright, so what is the meaning of this? Let us try to understand. So there are two equal chords. Okay, so equal chords are there. So let me call the equal chords to be AB and CD. Alright, so they are equal to each other. Alright, now the angles subtended by these equal chords with the center are also going to be equal. That's what the question is saying. Alright, so the angle subtended by chord AB with center is AOB. Right, so AOB is the angle subtended by chord AB with center, and similarly angle subtended by CD with center is COD. So according to the theorem, this angle and this angle, they have to be equal. All right, so that's what the theorem says about the chords with equal length. All right, now we have next is angle subtended by the side of a regular n-sided polygon inscribed in a circle with its center will be 360 degree by n. Okay, so you just need to memorize this. I'll show you the application of this in the problems. All right. Okay, let's have a look at the first problem for the day. That is, question says, in a cyclic trapezium, the non-parallel sides are equal and diagonals are also equal. That's what we need to prove. So there's a cyclic trapezium. So in a trapezium, two sides are parallel, right? And we have got two non-parallel sides. So we need to show that those non-parallel sides are equal and the diagonals will also be equal. All right, so this is my rough diagram for me. So any two sides are parallel. So here basically AB and DC are parallel. All right, and AC and BD are the diagonals. Okay, so that's what is written here. Now actually this problem is already done in your solved example. All right, so one of the part you will do by yourself by comparing the problem with your solved example. All right, so here we need to prove that the non-parallel sides, that is AD and BC are equal. All right, and the second part is AC and BD must be equal, that is the diagonals are equal. Okay, so to prove first part, I suggest you to refer page number 264. All right, because that is the solved example for the first part. All right, so second part I'll show you by myself. Okay, so with the assumption that we have already proved that AD and BC are equal, that is non-parallel sides are equal, so let us begin with the second part. Okay, so we have got in triangle ADC and BCD. So where is ADC? Let's say ADC and BCD. So we are talking about this triangle and this triangle. All right, so we have DC equals to DC, right? So DC is common to both the triangles. All right, now CAD is equals to CBD. So let us see where is CAD. So CAD and CBD, that is CBD. So this angle and this angle, they are equal because they are angles in the same segment, right? So this is my segment, CD is forming segment, and in this segment CD is forming this angle and this angle, so that they have to be equal to each other. All right, so that's why they are equal here. Now next one is AD is equals to BC, which is already proved in the first part, right? So AD and BC both are equal. So what is happening here? Let us see once again. So we have got this side and this angle, right? So we have, using SAS criterion, we have ADC and BCD both are congruent, right? So these two triangles are congruent. So this is equal, this is also equal, this is equal, and this is also equal, right? Because this is common. So that's why definitely the third side has to be equal. That is, by CPCT we have AC is equals to BD. All right, so with this we stop this particular problem. So you may pause the video to note down. Okay, let's see the second question for the day. So it is given that in the following figure, AD is the diameter of the circle with center O. So AD is the diameter with center O. Okay, so AB, BC and CD are given to be equal. So AB, BC and CD are given to be equal, and DEF is given to be 110. So we need to calculate AFE. No, this is AEF. All right, so please make the correction. So this is AEF and second is FAB. So we need to calculate these two angles here. All right, so let us see how to do that. So before we do that, let us do some construction out here. So the construction is we'll join these. All right, so that's what is written out here. Okay, so let's see the first part. So first part says AOD is the diameter. Right, so AOD is the diameter, so definitely, so we have AED equals to how much? 90 degree, because it is angle in a semicircle. Now since we are asked to find AEF, right, so AEF means we need to calculate this angle. Okay, and this angle can be calculated by subtracting this smaller, that is 90 degree, from this bigger angle. All right, so that's what is written here. So we have AEF will be equals to DEF, that is this bigger minus AED, that is this one smaller. All right, so let us put the value. So AEF turns out to be how much? 20 degree. So my first answer will be 20 degree. Now the second part says calculate FAB. So let us see where is FAB. So FAB means we have to calculate this whole angle. So how to calculate? Let us see. Now we know that these three chords are given to be equal, and we know that equal chords subtends equal angles with the center. So that means these two are equal. So angle subtended by chord AB is AOB. So this angle and similarly this angle will be equal, and similarly this angle will also be equal. All right, because this is also angle subtended by this equal chord. Okay, so that's what is written out here. AOB equals to BOC plus is equal to COD. All right, so because they are equal chords subtends equal angles at the center. All right, okay, so next thing is we know that if I add all these angles, I'll get a straight line, isn't it? So that's why it is written angle AOB BOC plus COD will give me 180 degree, because all of them forms a straight line if they are added to each other. All right, okay, so since they are equal, right, so again this and this, all of them are equal to each other. So that's why the value of each has to be 60, 60 and 60, because if they are 60, 60 and 60, then only we'll get 180 degree. So the value of each angle turns out to be how much? 60 degree. Now let us have a look at triangle OAB. So OAB means we are talking about this triangle. All right, now in this we have OA and OB equals to each other. OA and OB will be equal to each other because they are the radii of the circle. Okay, now we have angle AOB, sorry, it's angle OAB equals to angle OBA. Now as I said, since these two are equal, then obviously this is isosceles triangle. So that's why this angle and this angle, they will be equal to each other. All right, so that's what is written out here. All right, now by angle sum property of triangle OAB, that means sum of the angles will be 180 degree, right? So that's why OAB plus OBA will be equals to 180 minus AOB, right? So what is AOB? AOB is 60. So that's why sum of these two, that means this and this, that is this angle and this angle, has to be how much? 120 degree. Now we know that this is also equal and this is also equal to each other. So that's why definitely they have to be 60 degree each, because if this is 60 and 60, then only the sum will be 120 degree. All right, so that's why OAB and OBA both are 60 degree. All right, now let us have a look at cyclic quadrilateral ADEF. So ADEF is here. All right, now we know that DEF, so DEF means this angle, right? So this angle and this angle will add it to 180 degree, because in cyclic quadrilateral some of the opposite angles will be 180 degree. Okay, so from here we have DAF equals to 180 minus DAF, and how much is DEF? It is 110. So that's why DAF, that is, this angle turns out to be how much? 70 degree. Now we already know that this angle is 60 degree, and from here to here is 70 degree. So what is the total? So total is this full angle, isn't it? And that's what we need to find, right? FAB. So therefore FAB will be DAF, that is this angle, plus OAB, that is this angle. Okay, so we have the sum to be 130 degree. So that's why FAB is how much? 130 degree. So pause the video to note down. Okay, let us see the third question. So question says, if two sides of a cyclic quadrilateral are parallel. Now there's a quadrilateral whose two sides are parallel. That means the quadrilateral has to be a trapezium. Okay, so we need to show that its two sides are equal, other two sides, that is non-parallel sides are equal, and its diagonals are equal. So basically this question and question number 1 both are same, right? So you will try this by yourself. So this is going to be your homework. All right, so let us have a look at the next problem, that is question number 4. So in this question it is given that the given figure shows a circle with center O, and PQ, QR and RS are given to be equal. All right, so these marks represents that these sides are equal, and it is given that PTAS is given to be 75 degree. So we need to calculate POS, QOR and PQR. All right, so let us join these. All right, so after joining I'll get this figure. Okay, now it is given that PQ, QR and RS, all of them are equal, right? So basically, can I call them as equal chords? Yes, so they are actually chords and whose lengths are equal. So that's why the angle subtended by these chords with the center will always be equal. That is, this angle and this remaining angle will be equal to each other. All right, so we have this, as I said just now, right? So we have got this with us. Now let us see what is happening here. So arc PQRS, so PQRS means this arc. All right, so this arc subtends angle, or let me say in simple word, arc PS. Okay, so arc PS subtends angle POS at the center, and in the remaining part it subtends PTS. So basically what is happening here, this central angle, this full angle will be double of this, right? So that's why we have POS equals to 2 times PTS, that is 2 times 75, right? PTS is 75, so that's why this is given to be 150 degree. All right, so POS angle turns out to be 150. So our first answer is done, right? So let us see the next part. Okay, so I know that POS can be written as sum of 3 angles, that is this angle and this angle, right? So that's why instead of POS it is written POQ, QOR and ROS. Okay, so all of them are added here, and when they are added I'll get 150 degree, because this full angle is how much? 150 degree. All right, now since all of them are equal, right, as I said, all of these will be equal, so that's why the value of each will be how much? It will be 50 degrees. So 50 plus 50 plus 50 gives me 150. All right, so we have found QOR also. So QOR means this angle, so this angle is also how much? 50 degree. Now let us have a look at triangle OPQ. So triangle OPQ means this triangle, right? So in this triangle we have OP and OQ, right? So both are radii, so that's why these two will be equal. Now if this and this are equal, then this angle and this angle, they have to be equal to each other, isn't it? So that's why we have these two are equal, so they are angles opposite to equal sides, right? Okay, now we know that in triangle OPQ sum of the angles will be 180 degree. All right, now we have the value of POQ. So POQ is 50. So if I put this to be 50, then from here I get this angle plus this angle, that is OPQ plus OQP will be 130. So since both of them are equal, so that's why I'm writing 2 times OPQ here. So that's why from here the value of each angle turns out to be how much? 65. So this is 65 and this is also 65. Alright, so similarly we can prove that in other triangles also. That is triangle OQR. In this triangle also we have got this triangle, this angle and this angle will be 65 degree. Alright, and in the last part also we have got ORS and OSR will be 65 degree each. That is this angle and this angle both will be 65 degree each. Okay, so at last we have shown POS is 150 degree, right? So from here we have shown POS is 150 degree. Second is QOR is 50 degree, and at last we need to find what is PQR. So PQR means we need to find how much is this angle, right? So to find this angle we have PQR, that is this angle can be written as PQO, that is this angle plus this angle, right? So that's why it is written PQO plus OQR, which is 65 and 65. So altogether it is how much? It is 130 degree. All right, so you may pause the video to note down. Okay, let's have a look at the last question for the day. So question says, in the figure, AB is the side of a regular six-sided polygon. So six-sided polygon is there. Okay, so AB is one of the side of the six-sided polygon. Please remember that. Okay, and AC is the side of a eight-sided polygon inscribed in a circle. So this AC is one of the side of eight-sided polygon, and AB is the one of the side of six-sided polygon. So you just need to remember these two. Okay, so both the polygons are inscribed within a circle with center O. So we need to calculate the sizes of AOB, right? So this angle ACB. Okay, so ACB means we need to calculate this angle, and last one is ABC. So we need to calculate this angle. Alright, so let us begin. Now in this particular question we will make use of the theorem number 2, which was introduced in the beginning of the video. Alright, so let us see how to do this. Now if you see arc AB subtends AOB at the center, so if this is my arc AB, then this AB subtends angle AOB with the center, and in the remaining part, that means in this part, okay, so in this part the very same arc subtends angle ACB. So that's why AOB will be double of ACB. Alright, so that's why we have ACB will be half of AOB. Alright, now we know that AB is what? AB is the side, okay, one of the side of our six-sided polygon. That means number of sides here is how much? It is 6. Okay, and that theorem number 2 said that the angle subtended by one of the side with the center will be 360 degree by n, that is the number of sides. Okay, and how many sides are there in this? We have got 6 side, right? So AB is one of the side of six-sided polygon, so that's why n will be 6 here. So this central angle, that is angle subtended by this side, one of the side with center will be 360 by n, that is 360 by 6, which will be how much? 60 degree. Alright, so we have AOB equals to how much? 60 degree, that is this central angle is 60 degree. So our first answer is 60 degree. Now next part says we have to find ACB, and we know that ACB is half of AOB, right? So we have half of AOB, that is AOB is how much? 60 degree. So half of 60 is 30. So that's why this ACB is how much? It is 30 degree. Alright, so next is we need to calculate ABC. Alright, so before we calculate ABC, let us join O and C here. Alright, now here this AC is subtending angle AOC with the center, right? And in the remaining part, that is in this part, this AC is subtending angle ABC. So that's why I can say that this central angle will be double angle of ABC. Alright, so again this AC is what? AC is one of the side of eight-sided, right? So AC is one of the side of eight-sided polygon. So that's why this AOB will be how much? 360 by 8. Alright, so 360 by 8 is how much? 45. So this angle is how much? 45 degree. Alright, so we have, as I said, arc AC subtends AOC at the center and ABC in the remaining parts. So that's why ABC can be written as half of AOC. And how much is AOC? AOC is 45. So that's why ABC turns out to be 45 by 2, which is 22.5 degree. Alright, so you may pause the video to note down. Thank you very much.